my name is Manahil and my roll number is 17TE23. This channel is about the lectures of technical course, that is DSP, and this video is about our first lecture, that is Introduction to DSP. DSP is basically a technical course which is abbreviation of digital signal processing. Now what is DSP? DSP is very vast topic. Before heading towards its definition, let's divide it into components, that is digital signal processing. I explain each word step by step. So first word is digital signal that changes abruptly. As shown in figure, it changes from high to low, low to high. Another definition of digital is finite set of values to represent real world object, and this set is simplest finite set. As number of object increases, number of sample increases. There are two objects, so number of samples are 4, that is 0 0 0 1 1 0 and 1 1. Next, signal, physical quantity that change with respect to some independent variable, that is time, frequency and space, etc. For example, temperature, pressure, magnetic deviation, etc. Signal always come from some sensor. How we process those signal or those data limit. So we done processing. Processing is defined as that converts signal from one form to modified version of original signal. Why we need processing? To obtain desirable objective. Let's take an example. As we have a digital system and input of analog signal. So first we convert the analog signal into digital, then give it to the system. Processing is basically transformation through algorithm and techniques. Consider we have a chart or table of temperature measured in weather forecast. At different periods of time, the forecast report different temperatures. We do not need to consider each and every temperature at interval of time. We just see at what time we had maximum temperature, average temperature and minimum temperature. So we converted the signal into maximum and minimum value. Modified form of above table is 14 degree centigrade that show maximum temperature and 10 degree that show minimum temperature. For maximum and minimum, we design algorithm. This is the processing in DSP. So basically, DSP, it is mathematics, algorithm and techniques used to manipulate the signal after they have been converted into a digital form. Digital signal processing is concerned with representation, transformation, manipulation of signal on digital computer. What are the goals of DSP? DSP is recognition and generation of speech. Another goal of DSP is compression of data storage and transmission. Now we see the application of DSP in real world, that is digital crossover audio system, interference cancellation in electrocardiography, speech coding and compression, compact disc recording system, vibration signature analysis for defected gateways, digital image enhancement. DSP has revolutionized many areas in science and engineering. A few of these diverse applications are shown in here, that is space, medical, commercial, telephone, military, industrial, scientific. Applications of DSP are increasing in many areas. This will continue to have profound impacts and improve of our lives. Now we see the application in telecommunication, that is compressions and storage or sorting or searching. So first is compression. In telecommunication, we want fastest communication. So if we want to reduce the data transform from source to destination fastly, that it took less time. Let's take an example. We have three figures of same pixel, 300 cross 400, and channel capacity is 1 kbps. We want to transform these pictures from source to destination from X to Y. How much time is required to transform this signal from X to Y? We want to calculate the time. Then we apply the techniques of the DSP and then compare the time. So first figure is 300 cross 400. Calculate the time. It calculate 120 k, 120k, 120k divided by channel capacity. So total time is 360 seconds. That is approximately equal to 6 minutes. Now we apply DSP technique. As we shown in figure, alpha beta are similar, but object B is additional. So we crop the figure B and C similarly part object C, and we send only this part from beta figure, and from gamma figure we send this only part. So we reduce the data. Now we calculate the time. 120k from figure alpha, 15k from beta, 15k from gamma, and divide by channel capacity. So time is 150 seconds. Another compression technique, that is reduce the data 10 times. Alpha data is 120k reduced by 10 12k, beta 15k reduces 10 times 1.5 bytes, gamma similarly, and time is now 15 seconds. By using DSP, time is reduced from 360 seconds to 15 seconds. Another technique of DSP is sorting, that is the meaning searching. Data is arranged in ascending or descending order. It is possible only in digital signal because we have finite values in digital. We have two cases, sorted data and unsorted data. In sorted data, we want to search the number 5. We done 10 iteration, then we know there is no number 5. In case 2, we took 5 iteration and we know there is no number 5 because it is arranged in ascending order. It takes more time, it take less time, it take more computational cost, it take less computational cost. This is all about linear search. Another technique is binary search. Apply midpoint method. We attack directly on midpoint of given data. For example, we have given data that is sorted and arranged in ascending order. We want to search the number 12. We directly attack on the midpoint, that is 50. As we seen, 12 is less than 50. So numbers which are greater than the midpoint are discarded. We have only data left, that is 1 to 50. Then we applied again midpoint method, that is attack on the midpoint, that is 25. 12 is less than 25, so numbers greater than 25 are discarded. Now we have data only left, that is 1 to 25. We again apply midpoint method, that midpoint is 12. We want to search this number. By using their DSP technique, we have less iteration and it take less time and computation cost is less. This is all about today's lecture. Thank you.